All right. Hello, everybody, and thank you for that introduction by myself. It was very humbling. Good to be with everybody to do a presentation for the Rotorcraft seminar on lead-acid aircraft battery airworthiness. Again, my name is Chris Holder, and you see all my contact information there, my email address and my phone number. Please feel free to reach out to me anytime you have an issue. If it's on the weekends, you feel free to pick up the phone and give me a call and we will talk through it. So let's get started. So the agenda today, we've got a little bit of an introduction in history to Concorde for those of you who have not heard that before. We'll get into the technologies in the battery business right now, battery safety, some servicing and charging, cleaning, some installation eligibility, some STCs that we've got, optimizing battery service life, and then we will be done. So Concorde is a family-owned company started in the late 70s by the Godber family. Well over 40 years of experience manufacturing certified aircraft batteries. We brought the recombinant gas sealed lead acid battery to the aviation industry in the early 80s. The King Air was our first application, and we now have applications across all the GA market, the corporate market as well, and quite a few applications in the helicopter market. We are on about 70% of the U.S. military inventory in terms of applications. Our first application on the military side was the F-18, which we are on to this day. But what really put us on the map was the application for the F-117 stealth fighter. We worked on that for quite a number of years. And then in 1987, when that famous photo was published of the F-117 against a backdrop of the snowy Sierra Nevada mountains, we were informed that we did all that work not for nothing, and we were sole source on that aircraft until it was retired in 2009. It's hard to believe that that aircraft has been parked in the boneyard for 14 going on 15 years, but there you go. We also opened a second manufacturing facility in Austell, Georgia. If you're familiar with Atlanta, we were right off the south end of Charlie Brown Field. And that factory's been up and running for 8 years now and has helped us increase our capacity. As you know, lead times have increased for a lot of manufacturers. For us, it wasn't really a materials issue at all. It's been strictly demand. But as we've increased the capacity at that factory, it has allowed us to open up that envelope and try to get those deliveries out in a timely manner. So battery technologies, lead acid batteries have been around really since the Egyptian times, and the theory itself has not changed, but obviously the containers have. NiCads became very prominent in the 60s. You see those on helicopters, on the airliners, and in some corporate configurations, but we're seeing a really massive transition especially in the last decade, to lead acid because it is so much more simpler to operate. The downtime is quite a bit less. And then we've had lithium-ion that has slipped into our industry in the last 8, 9, or 10 years. There are a few applications out there. For instance, the Bell 505 comes out of the factory with a lithium-ion battery. If y'all remember back in May of 2011, there was a Dreamliner parked at the gate at Boston Logan, and it was not hooked up to ground power, and the batteries lit up, and the fire department was there in roughly 2 minutes to extinguish that fire, the professionals, and it took them over 2 hours to put that fire completely out. Lith burns a lot like magnesium. If you've ever seen a YouTube video of a nose wheel of an F4 Phantom lit up and burning, you know you can't extinguish that fire until you take all the oxygen out of the environment. So Lith burns a lot like that. Now, as the years have gone on, there have been battery management systems installed in the headspace of Lith batteries, but it still remains to be seen what's going to be done with that. And that kind of goes to this slide here. As I said, the protection and monitoring systems have been in place. It is extraordinarily expensive. If you go out there and price like for like batteries, you will find that the costs are extraordinary. Shipping constraints are also very, very difficult. It is a pretty healthy stack of paperwork that you have to go through to ship lithium-ion batteries. They have to be discharged down around 28 to 30% before they can be shipped. Disposal is also an issue. If any of you out there want to become the next billionaire, if you can figure out how to efficiently and cost effectively recycle lithium, then you will be well on your way to becoming the next billionaire. And is the industry ready? That still kind of remains to be seen. I mean, we work in an industry where the equipment that we fly on and work on leaves the ground. So it sort of remains to be seen where lithium ion is gonna land in our industry. But obviously, you know, weight is the holy grail, and lithium ion is half the weight and typically a third more power. And you know, as the saying goes, if I went to Bell or any of these other aircraft companies and said, hey, I could shave a couple of pounds off an existing battery, I get to play golf free summer, all summer long. If I shave 30 or 40 pounds off a battery, they name children after me. So, you know, weight is the holy grail. And we kind of jokingly refer to lithium inside the house as the heroin of our industry, because if you can shave weight and add power, it is a very compelling technology. So we'll see where that goes. So what you see in front of you is our component maintenance manual and our owner operator manual. You're going to see a picture of that CMM throughout this presentation. We affectionately refer to that as the Bible. Everything that you need to know about maintaining batteries is in that book. And you see our websites here, battery management, concordebattery.com. You can go in there and check all that out if you'd like to do it online. All of our batteries that are shipped come with a CMM inside the box. So if you are a Concorde user, you've probably got a pretty good handful of CMMs laying around. So let's deal with safety first. There's not a lot to talk about when it comes to safety in batteries, except they are extraordinarily heavy. So you don't want to drop one on the bridge of your foot, or it will absolutely ruin your day. Most of these batteries are in a polyplastic or a metal container in a sweaty environment that technicians work in. That can get pretty slippery. I'd ask that you not lift these batteries by the vent tubes. Your knuckles are not going to last too long, but if you break that vent tube, it's not repairable, and that is a very expensive mistake. So all of our turbine batteries have straps on the top of them. They can hold up to 8 times the battery's weight. So it makes it quite a bit easier the last decade or so that we've had those straps on the batteries. Also, for the Elcon style connected batteries with the 2 silver pins, you want to make sure if you're hauling those around, carrying them in your hands, and by the way, maybe a pair of engine gloves or anything to give you a good grip on those batteries, make sure that Elcon connector is facing outboard. And also make sure that the dust cap, which comes with every one of those batteries, is installed on that Elcon, because if you turn it around the other way, 13, 14, 1500 amps is going to hit you right in the belt buckle. And that is something that you just don't want to happen. So connector maintenance and terminal inspections, the MS3509 connector that slides onto the Elcons, you want to take a look at that, make sure those pins those spring-loaded pins are tight and you've got a good seal when you go onto the Elcon, because if they're not, you can get arcing. And if you arc that nickel into the copper where it shows, it becomes an unairworthy battery. So you want to clean and lubricate those surfaces about every 500 mating cycles. You want to check those contact sockets about every 500 mating cycles to make sure that they're contacting. As the sockets wear, the compression force, as we talked about, gets a little lower, and it can cause higher electrical resistance, and you get that arcing. So just make sure you take a look at those. Also, with the worm screw, you want to make sure that you're not misaligning, that when you run that worm screw onto the Elcon, you want to make sure that you're lined up, because that shear force over time can gradually wear down the connecting pins, and it's going to cause you to have to do some work there as well. So the first question on the table, should you or should you not store batteries on the ground on a concrete floor? So my grandfather was a P-51 pilot in World War II, flew every bomber but the 29, and his dad, he taught my dad, and my dad taught me, son, make sure you set batteries on a 2x4 in the garage, or the concrete will suck the energy right out of it. Well, that's not really the case. You know, back in the old days, there was a company called Rebat, And Rebat made batteries in a rubberized porous container, and those containers would actually leach. And the real purpose of putting them on the 2x4 was so that the 2x4 would soak up the acid as it came out of the battery. And of course, today we all know that these battery containers don't allow for leaching to happen. So the real issue here, the real answer to the question, is the temperature of where you store the battery. The cooler environment that you can store a battery in, a sealed lead acid battery, they will discharge much more slowly. We recommend 68 degrees or cooler. So the cooler the environment, the slower they will discharge. So flooded, gel, and sealed batteries are typically the three different types of lead acid batteries that are out there. Gel cells have been gone for a very, very long time in aviation. It was the first non-spillable carrier for acid in a sealed lead acid battery. But what we discovered very quickly is that gel develops voids. Think of a slice of Swiss cheese. If a void is up against any part of the plate, that part of the plate will not charge. And you only need your battery for two things: to start your aircraft or to provide you essential power to get you back down on the ground. So if you can't meet minimum capacity, then you're out of luck. So gel came and went very, very quickly. So that leaves us with flooded and sealed. The picture on the left is a picture of two different cells. The cell on the left is a sealed cell. The cell on the right is a flooded cell. You can see that brown line on the flooded cell. It doesn't go all the way to the bottom of the battery box, and that's because in a flooded battery, the plates need to sit on what's called a mud rest, because over time that free electrolyte will wash the active material off the plate. It settles down in the bottom of the box, and if it were to pile up high enough, touch the bottom of the plate pack, it would short that plate pack out. We also have to have some space in between the plates of a flooded battery to allow that electrolyte to slosh around in there. So not very big plates, not as many plates in a flooded battery. So the cell on the left, that's a sealed cell. You can see the brown line representing the plate that runs all the way to the bottom of the box. And we don't need the space between the plates in a sealed battery. So we sandwich those in between what's called an absorptive glass mat, an AGM mat. And we soak those to a little better than 90% capacity, sandwich them together so we can get more plates, and they're bigger plates, in a sealed battery. You typically have about 20% more power for a stock sealed battery than a flooded battery. But we also have a platinum series, and all of our 24-volt batteries, if you look at the sticker, says platinum series. And that simply means we've stuffed a few more plates into each one of those cell packs to give you about another 18% more power. So there really is a massive difference, and you can feel it at start for a platinum series sealed Concorde lead acid battery versus our old flooded batteries, which we stopped making about 10 years ago, or our competitors' flooded batteries. So known by a lot of different names, sealed batteries, recombinant gas, which actually explains how the batteries work. We have a proprietary vent system that recombines the gas, because all lead acid batteries vent, but we recombine the gas back into the mats. That's why you don't have to service them with fluid. There's two things that kill a lead acid battery: either chasing the fluid or not keeping them fully charged. And we've eliminated half of that, chasing the fluid. And we're going to explain to you the best ways to make that battery last by keeping that battery fully charged when you're not using it. They're also known as AGM batteries, which is probably the most common name that gets floated around, and then valve regulated sealed lead acid batteries. So these VRLA batteries, they have copper terminals, which, as you can see that copper in the cutaway. And again, if you see that copper poking out on the Elcon connector at any time, that is an unairworthy item. But those copper terminals improve the high rate discharge and make for very efficient engine starting. The intercell connections, this is probably the biggest part of the difference in our batteries. We are one of the last manufacturers that makes our batteries by hand. The only other way to make a battery is to do it in a robotic fashion. And when you do that, You reach down between the cell walls, which is that tall gray divider there, and you spot weld those cells together. And that spot weld is about the size of a pencil eraser. And because of the vibratory environment, particularly in the helicopter environment, those spot welds can crack and break, but what most often happens is it will warble out the hole created by the spot weld and allow fluid and gases to walk back and forth between those cells, and it will actually neuter side-by-side cells. So what you're looking at the top is what we call an over-the-partition connection. If you put your thumbs together, that's about how much lead there is for that one intercell connection. So these are very robust on the inside. They are designed to survive the environment that they're in, but that's one of the really big differences. And then the quantity and surface area of the plates determine battery capacity. Thickness affects the high rate discharge, which obviously we're talking about engine start, and that can greatly reduce your chances for a hot start. And as we all know, that's one of the most expensive mistakes we can make in our business. So let's talk a little bit about temperature versus power. You know, there's a marketing term called cold cranking amps that we're all familiar with, and that actually came into the automotive industry. Some of you who are old enough out there will remember the old Die Hard commercial in the early 70s. There were 7 or 8 cars out on the ice, and this guy had a plunger and a battery, and they were all connected, and he was going to start all those cars with that one battery and that cold. And he said, but before I do, I'm going to turn on all the lights and I'm going to leave them on for, I don't know, it was 10 or 15 minutes. And of course, everybody ran down to Sears and bought a Die Hard battery. But the trick was, had he not turned on the lights, he would not have been able to start those cars, because batteries don't like cold weather. They're a lot like us. And so you need to warm them up to get that power out of them. And so the energy transfer that turning on the lights created warmed up the battery enough to kick on all of the cars. So in the aviation business, it's IPP and IPR ratings. Initial peak power, that's measured at 0.3 of a second when you hit the switch or turn the key. And then IPR is the International Power Rating, which is measured 15 seconds down the line. So we've got one of our most popular turbine batteries here as an example, the RG380E44. At start, at room temperature, you're looking at 1,350 cranking amps. And then 15 seconds down the line, the IPR is 1,000. But look at the second column. At 0 degrees, look how much the power falls off. Cold weather operations are very, very difficult on a battery. And then you can see in the next column at -22, the power fall off is there, but it's not quite as bad. It is not quite as dramatic. In fact, we've proven over the last few decades that our batteries actually work better than NiCads at -20 and below. We've spent a lot of time up in International Falls over the years and man hours trying to figure out how to make these batteries work well. But the purpose of this slide is to show you, if you're doing cold weather ops, you need heater blankets. You need to be willing to get that battery. If you don't have heater blankets, get it out of the aircraft, get it in the FBO office, into the hotel room, anything to keep that battery warm. Otherwise, ground power starts are obviously what you need to do. So quite a few years ago, if you guys remember the story, there were some doctors down at the South Pole who were ill and they needed to be evacuated. And so Ken Borak sent that Twin Otter down there to pick them up. The RG380E44, I believe, was the battery that was on there. They were cold soaked to -60 that night. No hanger available. Got everything fired back up the next morning and got everybody out of there. So we are pretty confident in saying that Concorde is the preeminent cold weather operations battery. So some battery basics. We're going to talk about how to commission a battery, which is putting a battery into service, charging, cap checks, how to do it properly, that airworthiness question that seems to be a gray area for a lot of people, and then some scheduled inspections. So what does it take to put a sealed battery into service versus a flooded battery? Well, if you've got an old school flooded battery, you've got to fill it up with acid, shake it around a little bit, let that acid settle, put some more in there. And then typically what happens is somebody puts a 3-4 hour charge on that battery and lets it go into the aircraft, because it's a transient situation. In a lot of cases, there's a time constraint. And I'll tell you that if you charge up a flooded battery on its first charge for 3-4 hours, you are going to get that aircraft started. But if you do that, you have cut that battery's life by 50% at least. A flooded battery, its first charge is called a forming charge. And that has to be done the first time out. It's a 16-hour process. Then that battery needs to be capacity tested, because no flooded battery out of anybody's factory, including ours when we used to make them, are airworthy. So they need to be capacity tested. And then you're talking 3.5 to 4 hours of charging that battery back up before you can install it in the aircraft. So we're talking a day and a half if you do it right for a flooded battery. For a sealed battery, you're simply going to take it out of the box, check the open circuit voltage, and put it in the aircraft, because we high rate test, we capacity test all of our batteries, not once, but twice in our factory. And it's not a lot test. We do that individually on every battery, so you know it's ready to go out of the box. Now, I'd like to ask all of you a favor at this point. When you receive a Concorde battery into your shop, the first thing I want you to do is open that box and check the open circuit voltage. You know, I have a lot of distributors here in the United States, and I have to love them all equally, like I love my children. But some of them do a better job of rotating and managing their stock than others. And if you get a battery, you know, 25.8 is a full, or better, is a fully charged 24-volt battery, 25.8, or 12.9, 12.91 for a 12-volt battery. So if you're significantly below those numbers, and I'm talking 25.5 or below, 12.75 or below, that's an indication that that battery's been on the shelf for quite some time, and it needs to be boost charged. If it's anything below those numbers, I'd like you to reach out to me, and I'm going to get with a distributor and get you another battery. Because what would happen in this situation, if you didn't check that battery out of the box and it was lower on voltage, and you put it in the airplane and it fails in 6, 8, 10 months, you're not going to be angry at the distributor you bought it from. You're going to be angry at Concorde. But that obviously is not the whole story. So do me a favor and check the open circuit voltage of those batteries as you get them out of the box, and make sure that they are fully charged. Now, there's a lot of different types of chargers out there. There's only a couple of different kinds of charging methods. Constant potential is the type of charging that we do 99% of the time in our lives, charging up our phones or any other type of battery. Constant current charging is what we call a conditioning charge, and we're going to talk a little bit later about when you would put that charging method into play. And then you've got maintenance chargers, maintainers, whatever you'd like to call them. That's the black box you see there. That's made by VDC Electronics. It's called a battery minder. Our old venerable leader, Skip Koss, went to VDC many years ago and asked them to develop a maintainer that could be left on an aircraft battery for extended periods of time. Now, why is that important? Well, typical chargers that you would buy at AutoZone or Harbor Freight are designed for automotive batteries, and their charging rates are a few tenths of a volt higher. And it doesn't seem like much, but if you use those for an extended period of time on an aircraft battery, you can warp the plates, you can dry out the mats, do the exact opposite of what you're trying to accomplish. So using a battery minder by VDC, we don't make it, we don't sell it, but they allowed us to assist them in the development. So we do promote it because it is an extraordinary piece of equipment, and it really will extend the life of your battery if your aircraft are down for, say, weeks at a time. So look into that for your shop, your operation, if you've got aircraft that don't fly at least once a week and go at least an hour when they go. And then we've got a sister company, Advanced Power Products, that makes the charging units, the bench units you see there. They do charging, they do capacity testing. The big one, the VC8000, does it all. It also works on NiCad batteries. It's a 2-step charger, but they weigh 14 pounds. They're very portable as compared to the old Super Seeders. For example, they don't take up a lot of bench space, and they're very easy to use. I always like to tell the story that when my daughter Maddie was 5 years old, I spent about 20 minutes with her and taught her how to use it, because it is an extraordinarily easy piece of equipment to use. All right, so the question on the table is an aircraft airworthy with a dead or a discharged battery? Well, the simple answer is only if it was certified with one, and I don't know many that were. So here's where we get into critical safety issues. If an aircraft with a dead battery is started with an external power, how long does it take the aircraft charging system to recharge that battery? Well, the secret's in the watch. It takes about 3.5 hours or a little more to completely recharge. So here's the situation. You've got a helicopter on the ramp. You've got passengers. You've got an absolutely dead battery. So you call the line kit over to give you a ground power start, and away you go. And the problem is, if there was not enough energy in that battery to close the relay, that battery is getting no recharge at all. And if you wind up having a problem out over the water or in IFR conditions and you lose a generator, you're not going to have the essential power that you need to run the essential systems you need to get yourself out of trouble. So if you don't hear anything during this presentation, hear this. Please do not jumpstart aircraft batteries. It is not worth the risk. Take the time to get that battery out, get it recharged, or get yourself a new box of lead and then fly away. So here's the other one. You got a battery sitting there in the picture. The voltmeter says 25.83, and a lot of people would think, okay, that battery's in good shape. It's got a full charge on it. But in point of fact, that battery is in our lab. That's an RG390 there, and it has about 5, maybe 10 minutes of essential power in it. And why is that? Because there's so much sulfation on the plates that it doesn't have the capacity to take the charge through the sulfation. And I'm gonna explain that a little better to you later on. But the bottom line here is, don't let a voltmeter tell you what state of health is, because it can't. That's telling you what state of charge is. State of health is a whole different animal. And the only way to determine state of health is to do a capacity test. And we're going to talk about that in a few minutes as well. But point of the slide here is, don't confuse state of charge and state of health. They are two entirely different things. So at what time should an inactive lead acid battery be boost charged to prevent it from sulfating? Well, it's not really an issue of time. It's any time the voltages fall below 12.75 or 25.5, as we talked about earlier. Those batteries need to be boost charged for a few hours. The secret to keeping lead acid batteries working well for extended periods of time is to keep them fully charged when you're not using them. So this would apply to aircraft that are sitting for a period of time, or if you've got batteries on the shelf in the maintenance department. If they're in an air-conditioned environment, they're going to hold on to their energy a lot better. But if it's in a hot hangar, you need to take a look at those batteries about every 90, 100 days and make sure that they're fully charged. And if they're not, throw them on a battery minder for 3, 4, 5, 6, 8 hours, a day. Let them get fully charged, and then you're good to go. But any part of the battery or any part of the plates that's experiencing a discharge is immediately going to experience sulfation building up on the plates. And that sort of is the beginning of the long end of a lead acid battery. So keeping them fully charged is the key. So discharge rates. Flooded cell batteries lose 25% of their energy around 30 days, just a little above room temperature. But as you can see, you go 2 weeks in 95-degree temperature and you can discharge 25% of a flooded battery. And when I say a discharge, I mean this battery is sitting idle. There's no draw on it. Imagine it sitting out on the ramp, just sitting there. They will self-discharge, and the hotter they are, the faster it happens. But RG sealed recombinant gas batteries discharge 3 times slower than a flooded battery. And that's great news for operators that don't get to fly as much. The aircraft are out on the ramp. They don't have access to power to keep a battery on a battery minder. So they do discharge quite a bit slower. So that's great news for those of you who don't get to fly quite as much. You stand a whole lot better chance of getting your helicopter started if you're out there on a Saturday afternoon and you want to take it up for a spin. Is it okay to fast charge a lead acid battery? Well, this is where we differ with my friends at Guild. They do not like fast charging. Don't really know why, but we do. And why is that? Well, the general rule of thumb is the faster you can get energy back into a battery, the less opportunity there is for sulfation to begin to develop on the outside of the plates. In fact, our batteries can take up to 8 times the C1 rate. So if you've got an RG380E44 that we saw a little earlier, that's a 42 amp hour battery. So you're talking 320 amps if my math is correct. Now, you're not going to find a charger that's going to give you that kind of energy. But what we do encourage you to do, most chargers will go up to about 25 amps. Crank up the amperage as high as you can go and get that energy in there. Now, you will see that amp rate fall off rather quickly. But the key to all this is the last bullet point. You've got to control the voltage. If you don't do that, you can get what we talked about earlier, the warping of the plates, the drying out of the mat. So it's critical to control the voltage, the amperage, the current, pump as much of it in there as you can, up to 8 times the C1 rate. All right, capacity testing. Minimum capacity for airworthiness. Well, according to the FAA and GIL, 80% is minimum capacity. Now, the FAA does talk about 85% capacity in AC 4313-2B. And so Concorde's minimum capacity is 85%, and we get asked all the time, why is there a difference? And it is no more complicated than an added margin of safety. So that's why we do it. So cap testing. It is, as I said before, it is the only way to determine the state of health or the airworthiness of that battery. So how do you cap test a battery? Well, it's very simple. You want to first start with a fully charged battery. It's kind of like studying for a test. You know, you don't want to go into a test cold. You don't want to send a battery into a capacity test without it being full of energy. So make sure you put a battery on a charge for a few hours, depending on where it stands. Put a voltmeter on it, see where it stands, charge it up for a few hours. And then you're going to discharge that battery at the C1 rate, which is on the sticker in front of every aircraft battery. You're going to discharge that at that C1 rate, and obviously you need a bench unit to maintain that consistent C1 rate, and you're going to test it down to the endpoint voltage, which for a 24-volt battery is 20 volts, 10 volts for a 12-volt battery. When you get to that moment, you need to be 51 minutes into the test. That gives you 85% capacity. That battery's airworthy. Stick it back in the ship, and it's ready to go. Now, if it goes 54 minutes, then you've got a 90% capacity battery. And obviously, if it goes 160 minutes, it's 100% capacity. You will occasionally find some superstars that will go 103, 104, 105%, 61, 62 minutes. And those, you know, it's very interesting to me that these batteries go along the same assembly line, but occasionally you find one that is, for lack of a better term, the LeBron James of batteries. You know, it's just a superstar. So don't be alarmed is the point here. If it goes a little past 60 minutes, you've got a great battery on your hands. And then those capacity tests, the results of them will determine when your next capacity test is. So for piston aircraft batteries, the first test is at a year. If it passes above 90%, your next capacity test is at a year. If it tests below 90% and above 85%, your next capacity test is at 6 months. Now, for turbine batteries, which live a little bit more violent life, the tolerances are a little tighter. Your first one is at a year, but then if it passes above 90%, your next capacity check is going to be at 6 months. If it passes between 85 and 90, then your next capacity check is going to be at 3 months. Now, if a manufacturer of the aircraft wants you to do capacity tests at a little higher rate, then you need to cede to those manufacturers' wishes. But Textron on the Cessna jets is really the only one that I'm aware of. I'm not really aware of one on the helicopter side. So how often do you perform it? Well, we just talked about that. And again, refer to the component maintenance manual because all of that is on page 101 and it gives you all the information you need to know about how to do it. And then we also have a very interesting technical bulletin called TB14, Capacity Check Interval Adjustments. This primarily applies to longtime users of Concorde batteries. So let me give you an example. If you've got a helicopter and the battery lasted 3 years and failed at 3 years and 6 months, and installed another battery, second battery, and for simple math, it also passed capacity at 3 years, but failed at 3 years and 6 months. So the average lifespan of those two batteries is 3 years. On the third battery that you install in the helicopter, your first capacity test will be at 3 years. Now, if you read TB14, it will tell you this is subject to the flight profiles not being radically different year to year. So if you're running helicopters out to the oil derricks, or if you have a charter operation and you're flying pretty much the same legs, same hours, that sort of thing, then TB14 applies, and it can save you a tremendous amount of time and headache of getting batteries out and doing capacity tests. Now, compared to NICADs, it's a whole lot easier, but it's still something you got to do, and those batteries aren't light, as we talked about earlier. So this can really save you some maintenance time. Now, if things change, then it's time to go back to the CMM and do it like the book tells you. But TB14 gives you a lot of latitude if you're a longtime Concorde user and your flight profiles have not really changed. So what is sulfation? Well, that's what it looks like under a microscope. The picture on the left are new and spongy plates, very healthy. They'll accept a charge, but on the right, you see lead sulfate crystals. Now, it's not something that magically appears inside the box. If lead oxide is devoid of a charge, then it starts to turn into lead sulfate, and it acts like a barrier. If you've got a slice of bread and there's some mold on the outside of it, if you peel that mold away, a lot of times the inside of that slice of bread is healthy, and that's kind of how it works here with a plate. We've got to get rid of that sulfate on the outside because it acts like a barrier, and you can't get voltage into the healthy part, the spongy part of the plate, which is the internal part of the plate if you got sulfation. So that's the deal. So people ask me all the time, how and why do lead acid batteries fail? So when you went to A&P school, they taught you that lead acid batteries die on a curve. And typically where that curve comes from is the imperfect life that the battery leads. So you fly, sometimes your flights aren't long enough to completely recharge the battery. Maybe the helicopter sits for a week or two. The discharge part of the plate is going to immediately start to develop light sulfation. Now, if you go fly, a lot of times that recharge will turn that lead sulfate back into lead oxide. But over time, you keep doing this, and the sulfation is going to get heavier, harder, thicker, and it's not going to go away. And so you have less and less capacity for the plates, and that's where that curve comes from. So again, the secret to making batteries last really, really good lengths of time is to keep them fully charged when you're not using them. And we're going to tell you here in just a second how to fix a battery that has sulfation on the inside of it. Here's what we were just talking about. It's caused by leaving batteries discharged for long periods of time before you recharge. The repetitive undercharging, the short legs. And I'm thinking about your medical helicopter operators out there that are flying 8, 10, 12 starts a day. And sometimes the shortest leg is the 2-minute ride from the hospital back to the barn. So that's a very difficult environment for those batteries to live in. Parasitic loads, which we're going to talk about in a few minutes, that will slowly drain the battery and really drive you crazy if you don't know what's causing that battery to fail. The extended dormant periods that we talked about. And again, the longer you let them persist, the harder it is to reverse the sulfation. And eventually it gets so hard that you can't recover it, and you're going to have to scrap the battery. So what can be done to correct it? It's a conditioning charge. What are the parameters? How do you perform one? It's really very simple. Now, a conditioning charge, there's a myth out there that capacity tests will shorten a battery's life. That's not true. Capacity tests are simply a cycle. But a conditioning charge does remove a little bit of material off of the plates. But why are you doing a conditioning charge? You've got a battery that's failed capacity. So you have an option. You can either scrap it and buy a new battery, or you can perform a conditioning charge and you're trading material for life. an extra 8, 10, 12 months, or maybe a little longer, depending on how new the battery is, you can extend that battery's life. So yeah, you don't want to do more than a couple conditioning charges in a battery's life, but the reason you're doing it is to trade the material for some extra life. So a battery fails capacity test. It's already at the endpoint voltage of 20 volts or 10 volts. So now you're going to adjust the charger to what's called a constant current mode. And you're going to take 1/10 of that battery's C1 rate. So we talked about the 44. Let's do that again. A 42 amp hour battery, 1/10 is 4.2 amps. So we set that up on the charger. And then we're going to turn the volume all the way up on the voltage to about, usually it's 36.2 volts on a charger. And then you're going to set it up for 960 minutes, which is a 16-hour charge, and set it on its way. Now, if you're listening, somebody said, wait a minute, Chris, you said you've got to control the voltage, and you're right. But what you're doing here is a slow, steady crawl up the hill, and you're going to see voltages as high as 15 or a little better on a 12-volt battery towards the end of this, 30 to 31 on a 24-volt battery. But that's okay because we're doing this slowly and we're allowing that battery to turn that lead sulfate back into lead oxide. Now, every so often during this time, particularly the last 8 hours, but every couple hours in the beginning as well, you want to go over and touch the battery. Put your hands on the can. It's going to warm up, particularly in the last part of it, but you don't want it to get so hot that you can't touch it. So if you put your hands around the case of the battery and you feel a really hot spot, shut it down. The likelihood is that you've got an open cell in there or some damage of some sort. Shut it down. It's time to get a new battery. But once you perform that, you're going to let that battery rest for about 5-6 hours, whatever it takes to get it down to ambient temperature. And then you're going to perform another capacity test. I cannot begin to emphasize to y'all how effective a conditioning charge is. We've seen it over and over and over the decades, how many batteries get brought back to above 85% capacity, and they go back into service, and it takes some of the heat off of your budget. Again, the CMM is right there. The conditioning charge program is in there. It's very easy to follow. So we just went through that, so we'll skip through that. So some remedies, obviously, to prevent sulfation. Keep batteries charged. I've said it quite a few times today. When they're in any state of discharge, eliminate those parasitic loads. Use a battery minder if flight times are too short or the aircraft is sitting. Low rate constant current conditioning charge can also correct it, but we want to prevent it. So fly those aircraft, and if you're not flying them, use battery minders to keep them fully charged. When should you check the aircraft charging voltage? Annually, in the summer, in the winter, when your bride tells you to do it? Well, the answer is annually. And here is the chart. You may want to get your phone out and take a shot of that, but you will find this in the owner operator manual. It's not in the CMM, but it is in the OOM. 13.8 to 14.2 is the sweet spot for voltage regulators for 12-volt batteries. 27.6 to 28.4 for 24-volt batteries. If you have an adjustable regulator in the wintertime, run it up to the high side of that range. Okay, if it's summertime, run it down to the lower side of that range. You'll actually help extend your battery life a little bit. All right, so we've been talking a lot about dead batteries. What's the deal? Why do I have a dead battery? Well, more often than not, especially these days, because aircraft are getting more and more complicated. You've got USB ports and entertainment systems and new different kinds of avionics. So parasitic loads are very, very well, they exist. Let's just put it that way. They're around a lot more than they used to be. And certainly older aircraft experience this as well. But a parasitic load, by definition, is when everything's shut off on the airplane or the helicopter, and you've still got a draw on that battery. Now, when I was in the Marine Corps working on Cobras, that was my job. I was ankle deep in tail booms of helicopters, checking cannon plug pins one by one, looking for parasitic loads. It is a difficult thing to do. But if your batteries are failing early, this is the first place you need to go. Now, you need to be able to access the terminals to check for a parasitic load. And if you've got a traditional terminal style battery, you're simply going to take the negative terminal off, put the multimeter between the leads, between the negative terminal and the negative cable, and start with the lowest setting, or excuse me, the highest setting on the multimeter, and then turn it down. And if the needle starts to move or the digits start to move, you've got a parasitic load. But for Elcon style connected batteries, you can't get to them. So this little gizmo right here, which we call a PLTA, a parasitic load test adapter, and they're available through any distributor. You simply slide that on to the Elcon, then connect the aircraft to the battery, and you can see those leads hanging down there for your multimeter. Same process. Start with the highest setting, turn it down slowly. If you see the needle crawl or you see the digits come up on a digital multimeter, then you've got a parasitic load, and it gives you an idea of where to start, that this is the issue and we've got to go find it. Minimum level voltage is discharge for batteries. Well, you don't want to get them down below 9 or 18 volts. The answer is C. You don't want to get below 9 volts on a 12-volt battery or 18 volts for a 24-volt battery. If you do, you are going to get what's called reverse polarity. Skip used to say you need to catch this within the hour of it happening to have a 50-50 shot at getting a battery back. Now, I've heard a lot of stories over the years of Concorde batteries being flat below these numbers, people bringing them back, and they work and operate just fine. But here's the deal, folks. If you get below those numbers, go ahead and charge the battery back up. But the first thing you need to do is a capacity test, because you don't know if you've damaged that battery. And the only way to know if the state of health is airworthy is to do a capacity test. All right, damage. What kind of damage can you sustain? Well, obviously, if you drop a battery, you bust the lid, or you've got broken Elcon pins, or you break off those vent tubes, that's an unairworthy battery. You know, when we were kids, you take a piece of colored plastic and you bend it and you get that white crease. If you see that in the cans of our batteries, that's an unairworthy situation, because that battery has taken a heavy lick and it's probably done some damage internally. I get a phone call about once a month about this situation, concave and bulging sides. It is normal. Be happy to talk to you about it, but all sealed recombinant gas batteries have a positive 1 psi inside of them. So if the helicopter is at altitude and the battery burps, the vents burp, and you come down quickly, or the opposite, you can get the convex or the concave look. It can take up to a week for a can to readjust itself. So don't sweat it if it happens. If it goes further than a week, give me a call and we'll chat about it. But give it up to a week, and it will eventually adjust itself to its normal geometric look. But it is normal. If you see that, your battery's working just like it's supposed to work. The best way to clean a battery, it's really simple. Just a rag and some water. Please don't use solvents or detergents or anything like that. You'll damage the battery. You just need a lint-free cloth and tap water, and you're good to go. Now, here's an interesting factoid. In the culture we're living in, recycling is a really big deal, and the #1 most recycled product on the planet are lead-acid batteries, and they are 100% recyclable. There's not a lot of virgin lead left in the world, so please, if you have a recycling plant nearby, or you can take it to AutoZone. They'll give you a few pennies a pound for it. A lot of times you have folks in your area who will come pick it up for free. They won't charge anything. And obviously they make a little money on the lead for the recycling. But please don't throw lead acid batteries in the dump. They are recyclable, and they are very, very easy to dispose of in that way. So have somebody, typically, around where I live and the places I go, most shops have folks come and pick those batteries up. Lots of ways to install Concorde batteries. You go to our website, and there's a guide there for applications. On the piston side, there's AC 2327, which is for vintage aircraft, but we won't spend any time talking about it. But there's MODs, STCs, service bulletins, obviously coming on the TC or 337s. Lots of different ways to install our batteries. But please go to the website on the knowledge base side, applications and replacement guides, and you'll see it all right there. So let's talk just a few minutes about some STC approvals. The Leonardos, the AB 139s, and the AW 139s. You've got two options there for the main start battery, the RG380E44L or the 60L. And then the aux battery, which is a good size battery in this case, is the RG407. Again, all the things that we've been talking about, the increased power for cooler starts, reduces engine wear, lower cost of acquisition, lower cost of flight hours. There's no memory effect with these batteries. Sealed lead acid batteries ship hazmat free, air, ground, or sea. And again, just as we mentioned, they are fully recyclable. This has been a very popular STC over the last few years for the MDs, particularly the 500 and the 600s. That is the RG624. The feedback that we've gotten on this STC has been really dramatic. Folks are really, really pleased with the difference in power output and longevity of this battery in the MD applications. And then you've got the Delphines, the 365 series. That battery comes, the replacement for that one is the 44L, the RG380E44L, or excuse me, I'm sorry, I'm on the wrong one. For the Delphines, it's the RG365. But again, we've had some great feedback on that one as well. And then recently in the last couple of years, the Enstrom 480s and 480Bs, the RG641 replaces the Gill 764120 or the G641. Again, we've had a lot of great feedback on this one. It really does make a huge difference on those cooler starts. And then the S92As, you've got a couple different batteries here, depending on the aircraft, the RG292-102 or the 292-103As. And those are for the S92s. They're drop-in replacements. They're TSO'd. And again, reduced cost of flight hours and ships non-hazmat. So here is our sales team. Myself, Dave Chavone's up in the Northeast. Claudio Fonseca is down in Miami, and then Dave Vega lives out west. So we've pretty much got the country covered. Claudio also does manage Central and South America and Mexico for us. And then Gary Vickery is over in Wales. He handles Europe for us and Africa. Tony Vella's down under in Australia, so he's got the Australasia area. But focus on the customer service team. Shelly Johnson, Gloria Cordero, and Ashley Parker, those are three of the greatest customer service representatives that I've ever worked for in my career in aviation. Shelly's based out of our Georgia plant, so she's around from about 7 a.m. to 2 or 3 o'clock in the afternoon Eastern time. Gloria and Ashley are in our California plant, and they're there till about 5 o'clock Pacific time, which is 8 o'clock on the East Coast. So between the three ladies there, you've got some extended hours to get a hold of them at the plants, and they are very, very responsive. Send them an email, give them a call. They don't answer, they get right back to you, but they're very efficient and very, very knowledgeable. But feel free to reach out to any of us, either by email or by phone. We are kind of unique at Concorde. We answer the phone when you call us. We like to talk to you. We want to help you solve your problems. So please don't hesitate to reach out to us if you've got any questions. So in summary, open circuit voltage doesn't equal state of health. Capacity testing is the only way to determine airworthiness. Don't jumpstart an aircraft battery. Okay, that's what we've said early on. Please don't do that. And fundamentally, if you'll just keep your batteries fully charged without overcharging them, you're going to be in really, really good shape. Always refer to the component maintenance manual for instructions. That's where all the information that you need to get you through it. I pretty much thank y'all for joining us. And now I'm going to send it from me back to me.